Hey guys, today's goal, trying to write quicker here, is to multiply and divide exponents. Okay, so first let's start off by making sure we know all the pieces and parts when you see exponents. So let's say that you have 3 to the 4th power. The 3, of course, is your base, and the 4 is your exponent or your power. Okay, now 3 to the 4th power, that means that 3 is being multiplied by itself 4 times. That doesn't mean 3 times 4, it means 3 being written 4 times, 4 times, and it's multiplication in between. So when it's all written out like this, that way it's called the expanded form. All right, then the other form is the beginning, and that is your exponential form. Because you will hear me go back and forth between expanded and exponential. Make sure you write that down. Okay? Now, let's talk about multiplying exponents. Okay, so multiplying exponents. The first example that we're going to have is 5 to the 6th power times 5 to the 4th power. One thing I'm going to add up at the top here under multiplying exponents is one rule that you have to have, is that the base or bases must be the same. They must be the same in order for you to combine them, okay? So 5 to the 6th plus 5 to the 4th. Notice that you both have 5s. Now I know that I can combine them. So how do we do that? You have 6 5s to start with. So I'm going to write in expanded form first. 2, 3, 4, 5, 6. Okay, so you have 6 of them right here. Then it's multiplied by, then 4 more 5s. So 1, 2, 3, 4. So then you have the question, how many do you have altogether? So you have 10 altogether. So you write 5 to the 10th. Now, that's the expanded form. You don't have to write it all out like that. The shorter version, or the work that I would rather see you write, is this. Write your base down one time, and then write your first exponent, put a plus sign, and then your second exponent, because you are really just adding the exponents. So 5 to the 6 plus 4, and then you can write your answer, 5 to the 10th. Okay, so the rule that you need to remember is when the bases are the same, you must add the exponents. When the bases are the same, you add the exponents, and you only do this when there's a multiplication sign in between the two bases. Okay, let's try another one. This one we're going to, instead of a number, we're going to put in variables. So let's say you have x squared y times x to the 6th power y squared. All right, now you have to count out how many of each that you have. So I'm going to put all of my x's together. I have 2 x's in the front. Then I'm going to go across and get the other x's. I have 6. 1, 2, 3, 4, 5, 6. Then I have 1y. I'm just going to put a multiplication sign and bring it on down here. And then I have 2 more. 1, 2. So then combine everything. You have x to the 2 plus 6 times y to the 1 plus 2. Remember, when you see no exponent, it's a 1 there. It's just invisible. You just can't see it. So x to the 2 plus 6, that'll be x to the 8th power times y to the 3rd power. So the second step is what you should really show. The top is just the expanded form so you can see where all of the x's and y's come from. But the step after that, that's really the step that you need to show, that you're just adding the exponents when the bases are the same. Okay, now let's move on to the next type. This is when a power has a power. Oftentimes people get this mixed up. I don't want you to get this mixed up, so that's why I titled it a power to a power. Some people call it multiplying the exponents, or when an exponent has an exponent, because you do something a little bit different. You're not adding this time. All right, so let me give you this example. 4 squared, and all of that is to the 3rd power. So if you notice, it's only one base, but the base has an exponent, then that exponent has an exponent. So when that happens, it's really saying this: 4 squared times 4 squared times 4 squared. So you're saying 4 times 4 times 4 times 4 times 4 times 4. Altogether, you have 6. So instead of writing all of that out, you just say this: 4 to the power of 2 times 3. And that's 4 to the 6th. So you see the expanded form and you see the exponential form. Just multiply. Just put 2 times 3. Okay, let's try another one. All right, so we'll have negative 6. Negative 6 is to the 5th power. All of that is to the 3rd power. So remember, the base doesn't change. It remains the same. Okay, if it's negative, it's just going to come right on over. We'll do negative exponents the next time. But right now, since the base is negative, it's just fine. It doesn't matter. So you have to the power of 5 times 3. So it's negative 6 to the 15th power. And that's all you have to do. Okay? Now let's move on to dividing exponents. All right. Now, when dividing exponents, it's the opposite of multiplying exponents, I should say adding exponents. The only thing they have the same is this rule here. The bases must be the same. The bases must be the same. So let's try some. All right. So you'll see it looking like this, and there are other ways that you would see it, but I'm going to give you the most general way that you'll see it. 7 to the 6th power divided by 7 to the 2nd power. So the way that this works out in expanded form, you have you have 6 sevens on top, 1, 2, 3, 4, 5, 6. And then on the bottom, you have 2. Now, this is just like canceling out from top to bottom. 7 divided by 7 is 1. 7 divided by 7 is 1. There are no other 7s to cancel out. So you have 4 of them left. So that means 7 to the 4th power. But do you have to write it out in expanded form? No, you don't. All you have to do is write your base, then your exponent minus the other exponent, because that's really all you did. You really took 6 7s, and then you subtracted 2 of them, which you got 4. So that's all you would have to show is your subtraction. Okay? Let's try one more. We're going to use a variable this time, just to show you that it's the same no matter what, as long as your bases are the same. So you have x to the 12th power over x to the 4th power. So I want you to show it the other way, not the expanded form, but the exponential form. X to the 12th minus 6, and then that equals x to the 6th power. Okay? All right, so, and you know what? Let me fix that because that's not what it was intended to be. That denominator is not 6, it is a 4. So let me go ahead and fix that. I want you to fix it too. That is a 4. That is a 4, which means this is going to be an 8. All right? So we'll practice this more in class. Make sure you have your parents go ahead and do this. Put an X there and put a line, and go ahead and get your parents to sign it. I'll see you in class.